Welcome. Today we are looking at chemical bonding, focusing on intermolecular forces. This is a key topic in your chemistry exams for SS1. Pay close attention. Let us begin. First, let me explain what intermolecular forces are. Intermolecular forces are the forces of attraction that exist between molecules. They are different from intramolecular forces. Intramolecular forces are the forces within a molecule. They hold atoms together. These include ionic bonds, covalent bonds, and metallic bonds. Intermolecular forces are the forces between molecules. They are much weaker than intramolecular forces. However, they are very important. They determine the physical properties of substances. They affect melting point, boiling point, solubility, and viscosity. The three main types of intermolecular forces are van der Waals forces, dipole-dipole forces, and hydrogen bonds. Van der Waals forces are the weakest. Hydrogen bonds are the strongest. Understanding intermolecular forces helps explain why substances behave the way they do. For example, why water is a liquid at room temperature, while hydrogen sulfide is a gas. The answer lies in the intermolecular forces. Now let me explain van der Waals forces. Van der Waals forces are the weakest intermolecular forces. They are also called London dispersion forces. They occur between all molecules, whether polar or nonpolar. They are caused by temporary dipoles. Electrons in a molecule are constantly moving. At any instant, the electrons may be more on one side of the molecule. This creates a temporary dipole. This temporary dipole induces a dipole in a neighboring molecule. The temporary dipoles attract each other. This attraction is a van der Waals force. The strength of van der Waals forces depends on the size of the molecule. Larger molecules have more electrons. They have stronger van der Waals forces. This is why larger molecules have higher boiling points. For example, the boiling point of methane is -161 degrees Celsius. The boiling point of octane is 125 degrees Celsius. Octane is a larger molecule. It has stronger van der Waals forces. Van der Waals forces are also called London forces, after the physicist Fritz London. They are present in all molecules. They are the only intermolecular forces in nonpolar molecules. For example, the noble gases are held together by van der Waals forces. They are gases at room temperature because the forces are weak. The boiling points of noble gases increase down the group. This is because the atoms get larger and the van der Waals forces get stronger. Now, let me explain dipole-dipole forces. Dipole-dipole forces occur between polar molecules. Polar molecules have a permanent dipole. They have a positive end and a negative end. The positive end of one molecule is attracted to the negative end of another molecule. This attraction is a dipole-dipole force. Dipole-dipole forces are stronger than van der Waals forces. They occur in addition to van der Waals forces. For example, hydrogen chloride is a polar molecule. It has dipole-dipole forces between its molecules. The boiling point of hydrogen chloride is -85 degrees Celsius. This is higher than the boiling point of fluorine, which is -188 degrees Celsius. Fluorine is nonpolar. It only has van der Waals forces. The dipole-dipole forces in hydrogen chloride make it harder to separate the molecules. The strength of dipole-dipole forces depends on the polarity of the molecule. More polar molecules have stronger dipole-dipole forces. The molecules with larger dipole moments have higher boiling points. Dipole-dipole forces are important in many chemical and biological processes. Now let me explain hydrogen bonds. Hydrogen bonds are the strongest intermolecular forces. They are a special type of dipole-dipole force. They occur when hydrogen is bonded to a highly electronegative atom. The highly electronegative atoms are oxygen, nitrogen, and fluorine. In a hydrogen bond, the hydrogen atom is attracted to the lone pair of electrons on the electronegative atom of another molecule. The hydrogen bond is represented as XH, Y. X and Y are the electronegative atoms. The hydrogen atom is covalently bonded to X. It is attracted to Y. Hydrogen bonds are stronger than dipole-dipole forces and van der Waals forces. They are about 1/10 the strength of a covalent bond. Hydrogen bonds are responsible for many important properties of substances. For example, water has a high boiling point because of hydrogen bonds. Water boils at 100 degrees Celsius. Hydrogen sulfide has a similar molecular weight, but it boils at -60 degrees Celsius. Water has hydrogen bonds. Hydrogen sulfide does not. The hydrogen bonds in water require more energy to break. This is why water has a high boiling point. Hydrogen bonds are also responsible for the structure of ice. In ice, the water molecules are arranged in an open structure. The hydrogen bonds hold them in this structure. This is why ice is less dense than water. Ice floats. Hydrogen bonds are also important in biological molecules. They hold the two strands of DNA together. They give proteins their shape. They are essential for life. Now let me explain the relationship between intermolecular forces and physical properties. Intermolecular forces affect several physical properties. Melting point is affected by intermolecular forces. Substances with strong intermolecular forces have high melting points. More energy is needed to overcome the forces. For example, water has a high melting point because of hydrogen bonds. Boiling point is also affected. Substances with strong intermolecular forces have high boiling points. For example, water has a high boiling point because of hydrogen bonds. Viscosity is the resistance to flow. Substances with strong intermolecular forces have high viscosity. The molecules are held together more tightly. For example, glycerol has strong hydrogen bonds. It is very viscous. Surface tension is the force that holds the surface of a liquid together. Substances with strong intermolecular forces have high surface tension. Water has high surface tension because of hydrogen bonds. Solubility is also affected. Like dissolves like. Polar substances dissolve in polar solvents. Nonpolar substances dissolve in nonpolar solvents. This is because the intermolecular forces must be similar. For example, salt dissolves in water because both are polar. Oil does not dissolve in water because oil is nonpolar. The intermolecular forces in oil are different from those in water. Now, let me explain the concept of polarity. Polarity is the distribution of electric charge in a molecule. A molecule is polar if it has a positive end and a negative end. This happens when the molecule has polar bonds and an asymmetrical shape. A polar bond is a bond between atoms with different electronegativities. The more electronegative atom pulls the electrons towards itself. This creates a dipole. The molecule is polar if the dipoles do not cancel out. For example, water is a polar molecule. It has two polar OH bonds. The molecule is bent. The dipoles do not cancel out. The oxygen end is negative. The hydrogen end is positive. Carbon dioxide is a nonpolar molecule. It has two polar C equals O bonds. The molecule is linear. The dipoles cancel out. The molecule has no net dipole. Polarity affects intermolecular forces. Polar molecules have dipole-dipole forces. Nonpolar molecules only have van der Waals forces. Polar molecules are soluble in polar solvents. Nonpolar molecules are soluble in nonpolar solvents. Now let me explain the concept of hydrogen bonding in biological systems. Hydrogen bonds are essential for life. They hold the two strands of DNA together. The hydrogen bonds between the base pairs hold the double helix together. This allows DNA to replicate and carry genetic information. Hydrogen bonds give proteins their shape. The protein folds into a specific structure. This structure is held together by hydrogen bonds. The shape of the protein determines its function. Enzymes work because of their shape. Hydrogen bonds are also important in the structure of cellulose and starch. They give plants their strength. They store energy. Hydrogen bonds are also important in the structure of antibodies and hormones. They allow these molecules to bind to their targets. Now, let me explain the concept of intermolecular forces in everyday life. Intermolecular forces explain many everyday phenomena. Why does water wet a surface? Water molecules are attracted to the surface by intermolecular forces. Why does oil not mix with water? Oil is nonpolar. Water is polar. The intermolecular forces are different. They do not interact. Why does soap remove dirt? Soap molecules have a polar head and a nonpolar tail. The nonpolar tail dissolves in oil. The polar head dissolves in water. The soap surrounds the oil and carries it away. Why does glue stick? Glue forms intermolecular forces with the surface. Why does water climb up a narrow tube? This is capillary action. It is caused by adhesion and cohesion. Adhesion is the attraction between water and the tube. Cohesion is the attraction between water molecules. The water climbs up the tube because of these forces. A common exam question asks you to explain the three types of intermolecular forces. Here is a sample answer. The three types of intermolecular forces are van der Waals forces, dipole-dipole forces, and hydrogen bonds. Van der Waals forces are the weakest. They occur between all molecules. Dipole-dipole forces occur between polar molecules. Hydrogen bonds are the strongest. They occur between hydrogen and oxygen, nitrogen, or fluorine. Hydrogen bonds are responsible for the unusual properties of water. Another exam question asks you to explain the relationship between intermolecular forces and boiling point. Here is your answer. Substances with strong intermolecular forces have high boiling points. More energy is needed to overcome the forces. For example, water has a high boiling point because of hydrogen bonds. Hydrogen sulfide has a low boiling point because it only has dipole-dipole forces. The boiling point increases with the strength of intermolecular forces. Another exam question asks you to distinguish between polar and nonpolar molecules. Here is your answer. Polar molecules have a positive end and a negative end. They have polar bonds and an asymmetrical shape. Nonpolar molecules have no net dipole. They have nonpolar bonds or an symmetrical shape. Polar molecules have dipole-dipole forces. Nonpolar molecules only have van der Waals forces. Polar molecules dissolve in polar solvents. Nonpolar molecules dissolve in nonpolar solvents. Let me give you a quick summary. Intermolecular forces are forces between molecules. They are weaker than chemical bonds. The three types are van der Waals forces, dipole-dipole forces, and hydrogen bonds. Van der Waals forces are the weakest. Hydrogen bonds are the strongest. Intermolecular forces affect melting point, boiling point, viscosity, surface tension, and solubility. Polarity determines the type of intermolecular forces. Hydrogen bonds are essential for life. They hold DNA together and give proteins their shape. Practice these concepts. When you have them down, move to topic 8.